Good afternoon. And today we have Mr. Manan Gupta from planetscale.com. And today he will be talking about a project called Vitess, which is a open source distributed database management system. And a little bit introduction about Manan. I had the privilege of meeting Manan at IIT Guwahati, and he completed his BTech at IIT Guwahati. And he also represented IIT Guwahati as well as India in ACM ICPC 2021 at Moscow, as well as he had a lot of quantitative experience. He had interned for Quadai, but now he is focusing on this open source query serving systems, especially Vitess. So Manan,
Yes.
please take it over from me.
All right. Thank you very much for the introduction. And hello, everyone. I'm going to be talking about Vitess, as Saptarshi pointed out. So let's dive right in. So Vitess is an open source database. And the first thing that I want to talk about is exactly why these new SQL databases came into the picture, what was required by model applications, which weren't being met, which requirements weren't being met by original databases that you had, like MySQL and then MongoDB and so on. Um, so when you're running an application and you have a database, the requirements that you have generally fall into these four categories that you want very high performance from them because they're going to serve a lot of QPS queries per second. You require them to be scalable because you're going to hammer them with so much QPS, you need them to be distributed across the world so that servers closer to your users can be provided. You want high uptime and availability so that even if something goes wrong, your database does not go down. And of course, the most basic principle of all databases as part of ACID, that you don't want to lose any data. So all of these requirements are what make databases so hard because you have to ensure all of this in a distributed system. Original MySQL systems, if you remove the scalability part from this and you just keep performance, uptime, and no data loss, to some extent, they were able to solve those problems by just having a single MySQL. And initially, when they required scaling problems, they would just use more hardware, stronger hardware, more CPU, more memory. But that has its limits, as we all know. So that's where NoSQL systems came in, that they would let you, they were highly scalable, they provided the performance. But the issue there was that they took away the structure of the data. So a lot of the things that applications were dependent on the SQL data for verifying, like foreign constraints or all the others, were just completely gone in NoSQL. Now you just had kind of like a key value store, and it's up to the application to verify that it's inserting the correct data. You can end up inserting null values. All of those things came as a problem. So that's what the gap that new SQL bridges between SQL and NoSQL. It provides structure like SQL. You can query it with the same structured query language.
Online join.
And it provides a lot of scalability like NoSQL. There are a lot of new SQL databases that have emerged over the years. Vitess, CockroachDB, TiDB, there's VoltDB, there's many others. I personally am just going to talk about Vitess today. But it would be interesting for you all to take a look at the other databases as well and compare the architecture of these with Vitess. Would be a good learning exercise. So let's start. As I said before, Vitess is a cloud-native database. It is massively scalable, highly available, and it works with MySQL 5.7 and 8.0 compatibility. What this means is that it is a drop-in replacement. If you have a system that is working with MySQL, you can directly use Vitess instead of that MySQL instance instead of it, and it should be all seamless to the application. As a DBA, you would know the differences. You would know a few things. You would have to set up a few things. But from the application standpoint, you won't need any changes. It would still continue to work like it used to. Cloud native here means that Vitess can run on the cloud. What that generally means is the architecture is microservices based. Each individual component node can be run separately. You can have multiple instances of it, and them going down can be handled in Kubernetes. So we'll go over the architecture of Vitess in a while, and you would see that there are a lot of small components to Vitess, and all of them together make up Vitess. So each individual component only handles some part of the complexity, and that going down is not much of an issue because there is high resilience in all of those terms. Vitess is a CNCF graduated project. CNCF is a cloud-native computing foundation that manages a lot of open source cloud-native projects. They have a few classifications of projects like sandbox, incubating, and graduated. Vitess graduated a while ago. It is completely open source, supported by the community, written in Golang, and it has the Apache 2.0 license. So these are few of the companies that have used Vitess or are using Vitess currently. Slack is 100% on Vitess. I'm sure you guys have heard of Slack and GitHub. Both of these companies are using Vitess. YouTube is where Vitess was built, and PlanetScale is the company that I work on, is also built on top of Vitess. So Fair Cash, it's one of the payment gateways in the United States, popular outside India. That's also 100% on Vitess. They actually migrated just recently. So the goals with Vitess is that it needs to work with database frameworks, ORMs, all the legacy codes and third-party applications that have been already written way before in the past. So you could have like applications like Rails, for example, Ruby on Rails. On all of these applications, they have their migrations, their entire code written in the intent that it would work with MySQL or some other MySQL compatible framework. And Vitess needs to work with all of that. So the major question that arises is that Vitess architecture has to enable transparent database operations such that the application is not aware that it's doing anything different rather than just being connected to a MySQL instance. This is where a lot of complexity from the query serving side also comes in, which we're going to go over in a while. But the first thing, and this is the part that is somewhat important. I'll stop for questions after I talk about this a while. And these are some of the concepts that come into the Vitess when these are the terminology you require when you start coming into Vitess to understand exactly how it works. So in Vitess, we have a concept called key space, which is a logical equivalent of a database, and a shard is a segment of it. So the way that Vitess ensures massive scalability is by splitting database into two or more different parts. For example, you have one table, let's say commerce as a table, which has two columns for now, just assume customer ID and email. And in a single MySQL instance, you would basically store all your data, let's say these 3 rows in a single MySQL instance. But when you start hitting the limits of your scalability, that's when you split it into 2 parts. So now you no longer have a single database. You actually have 2 separate databases separately running on different servers, each storing only part of the data. And together they have the entire data stored between them. So if you look at this, let's say that the commerce database has now been split into 2 parts. You have -80 and 80- as shards. The first shard is only having like 2 rows, and the second shard has 1 row. Together, they have the entire data, but individually, they each only hold some of the data of the shard, which is where the logical concepts come in. So commerce in Vitess is now a logical database. It's like a key space, which inherently has 2 more databases running on MySQL separately. On a logical level, they together make the database. So that's what a key space is, and each individually, these parts are shards of that key space, which hold some segment of the data. Don't worry about the name of the shards, -80, that's a separate concept we'll go over sometime if we have the time for it. But essentially, they're just splitting the entire plane of data into 2 parts. These are basically hexadecimal numbers in the higher order format. So 80 onwards is the second shard, and everything up to 80 is the first shard, where the first bit is more significant. So you essentially just split the space into 2 halves. And the sharding scheme is essentially just the way that you split the data. So for example, you have these 3 rows, but how do you decide which row goes into which shard? Does it go into the first one or the second one? And this is what your sharding scheme is, how you choose to answer that question. Over here in this example, I've chosen a very simple sharding scheme. If you're looking at it, you would probably be easily able to figure it out. It's just the parity bit of the customer ID. So if it's odd, it's in the first shard. If it's even, it's in the second shard. So you can have any kind of sharding scheme that you want. Sometimes, especially when you're running real actual world databases, your sharding schemes become way more complex because it's not just dependent on your customer ID anymore. For example, let's say you're talking about Amazon and they want to shard their database. They would want to store all the information about a certain customer in the region in which the customer has come in, right? For example, if I'm using Amazon, they would want my data to be stored somewhere closer to India because if I go to my profile, I'm going to be accessing it from India. It's more likely I will be doing it that way. And if there's a customer in the United States, they would want their data to be stored there. So once they shard and they have multiple shards located all across the world, their sharding scheme would also be taking into account which region the customer has created his account. All of these things come into play. So your sharding scheme can actually be very complex. For most of the examples, we're going to focus on simple sharding schemes where you're only using one column and you're just applying some function on it to get back a simple value, whether it's going with the first shard or the second shard. In this simplest of easiest of cases, it's basically just modulo 2. You do modulo 2, whatever you get back is the shard that you send the data to, either 1 or 2. So before we move on, this is the part that I want everyone to understand very well, the key space, the segment, and how they correlate to a database. So you're essentially running two databases in this scenario. They together make a key space. That's your logical database as an equivalent. I'm going to pause it for a couple of seconds to take in any questions if someone has any. You can put them in the chat as well if someone's watching online and they have any questions. Okay, so let's move on. Even during the remainder of the session, if you have some questions that arise, feel free to pause me, ask me to stop, and I'll take those questions right away. Okay, so once you understand this concept of sharding, let's go over the other components of Vitess. Okay, let's move on. So when you run a single MySQL instance or a single database in a non-sharded environment, you generally don't just run single MySQL, you actually run multiple instances of it for high availability, which are all replicating from your primary. So essentially you have a cluster like this where you have one single MySQL instance, which is the primary, and it's the one that's taking the writes. The other replicas are replicating from it, so they eventually have the same data there as well. If the primary goes down, you can promote one of the other tablets, and that is how you generally run a MySQL cluster. In Vitess, to each of the MySQL cluster, MySQL instances, we have an additional process attached to it. It's called the VT tablet. VT here, on all of the nomenclature of every component of Vitess, we append VT. VT basically is a short term for Vitess. So VT tablet is a Vitess component that runs along with MySQL. It interacts with the MySQL server, and it basically manages the state of the MySQL just to ensure that what they're replicating from gatekeep any queries. There are a few other features like query consolidation, hot row protection, and others that come in through the VT tablet, but we're going to talk about that a little later. Essentially, it's just a sidecar that's attached to your MySQL instance, and it's providing a little more functionality like managing it and gatekeeping a few of the queries that come in, access control, and a few other things. So you now have one MySQL instance and a few other MySQL instances replicating from it, each having a VT tablet of its own. But this makes one cluster. And if you're running a sharded system, you actually would have multiple of these clusters. So each shard would look like this. That each shard would have a primary VT tablet with a MySQL instance, and then replicated VT tablets and MySQL instances. So in the commerce example that we saw, this would have been shard -80, this would have been 80 hyphen, and more if you have more key spaces, more databases in your database that you're running, so you would have more. So this is what your in production multiple clusters would look like, that you have multiple of those, each having their own primary with VT tablets. But this is where the next thing comes in. Now that you have so many of these VT tablets, each being a primary of its own, holding only a subset of the data, that's not really where you can route the queries coming in from the application. Application needs to have a endpoint where it can just query. It can't really go to 3 different VT tablets and ask for partial data from all of those. So this is where the next component of Vitess comes in. It's called VTGate. And this is essentially a stateless proxy. It holds, it knows which tables are located where. It has schema tracking enabled inside it. And this is what is responsible for routing queries that come in from the user. Not just routing queries, it does a few more operations. We'll go over them in a little more detail later on. But this is essentially the endpoint that any user would connect to. And this is what impersonates a monolithic MySQL server. So if, for example, someone does a select star from the commerce table, it would be VTGate that would essentially collect the data from the first shard, collect the data from the second shard, put them all together and send the response back as a single response to the client. So the client would not need to know the complexities of how the data is sharded, where what lives. They connect to VTGate, they give them MySQL query, VTGate handles everything and returns it back. It is a stateless system. So the next follow-up is that you can run multiple of these VTGates, as many as you want. So if you want to scale your read traffic, you just increase your VTGate instances, because all of those will be able to handle read traffic. You would require some handling on VT tablet side as well, but essentially because these are all stateless, you can spawn as many as you want in different regions closer to the servers that you have actually running. And this is how generally a cluster then looks like. Once you have this, let's just talk a little bit about routing queries on VTGate and exactly how that goes on. I explained it a little while ago, but here we have an example as well. For example, if someone does something like this, that they connect to VTGate, they say that they want to use commerce and they want to select customer email and ID from customer where ID is for. Now we just saw that the way that we had sharded the data, it's not hard to figure out where the data would live if you know the customer ID. In this case, we do, it's customer ID 4. So you know that you have to go to which shard, and VTGate was essentially just send this query to that shard, gather that data and return it back. We have a few other components. This between VT gates and VT tablets, essentially you've covered all the components that are involved in the query serving path. The query comes to VT gate, it goes to VT tablet, collects the data from MySQL, returns to VT gate. Some post processing happens in case you have to do some kind of ordering, because again, if you're going to collect data from multiple sources, you sometimes might need to run a merge sort and few other of these things. We look at that in more detail when we come to the demo of it. But these two components essentially make up the query serving side of Vitess. We have a few other components as well. The first of which, the most important of which, is the topo server. Because these databases inherently are stateful, you need to store that state somewhere. For example, what the schema is, where the shards are, what is the host name of the tablet, some of these things. Because VTGate needs to discover all the VT tablets. It needs to know who the primary VT tablet is in order to query it, send write traffic to it. So all of that gets stored in the topo server. Topo servers are essentially replicated key value stores, which offer, they don't generally handle very high QPS, but they offer very strong consistency. For that reason, generally we use etcd, Zookeeper, Consul, some of these. They generally run Raft or Paxos, one of the distributed algorithms themselves, to ensure that none of the data gets lost. The data that we do store there is a very small data set. It's essentially just metadata information. So more often than not, it's mostly cached at VTGate. So you very rarely change it. For example, you don't expect in your everyday operations to be bringing up new clusters or new tablets, stuff like that. So more often than not, it won't change a lot. So the caching at VTGate holds. And it's very rarely that you would have to update it. So we have a watcher on the topo server, and that's how it works. The other thing that we have is, once you have a topo server, you also need a process that can control some of the stuffs to it, like reading it, writing it. It's an API server that can do a few other operations. Maybe you want to change what your current primary is for maintenance. You want to reparent your current tablet to a different one. All of these operations happen through another component of Vitess. It's called VTCTLD. It's basically Vitess Control Daemon. The short form for that, VTCTLD. It uses locking and it operates on all the tablets. You can do a few other things as well. You can change the type of it and other operations. We take a look at that. This is essentially how the overall Vitess architecture looks like. You have the application on the side. You have VT gates. In front of the VT gates, you can put a load balancer on top. And that's how your queries come in. We've already looked at the VTCTLD, the topo server. You have multiple shards. You don't necessarily need to keep two. You can keep resharding, increase the number of shards you have. Within each shard, you would have a primary VT tablet with MySQL and replicated VT tablets as well. There are a couple of components that we haven't talked about so far. The first of them being VT admin. That's essentially the Vitess admin page. So it's a GUI component which shows you how your cluster looks like. You can do a few of the operations that you would do through VTCTLD in a user interface as well. So it's pretty neat that way. And the last is VT-org. This is the component that I've been working on for a while, over the past year and a half. It's Vitess orchestrator. It's essentially used for high availability. So this is the component that polls all the MySQL and the VT tablet instances for their health, sees if something is wrong, and ensures that the cluster keeps working as intended. So for example, if a primary server crashes, for example, let's say there was a OOM in MySQL, those are pretty common, happen for various reasons. But let's say something like that happens. You don't want your entire shard to go down. You don't want your VT plates to start complaining that you can't run queries anymore. So what VTR does is that it immediately reparents to a different tablet, and then it waits for other VT tablets to recover. It does RNG-TID protection. It has a few other things that it takes care of. We can talk about those if you have time. But this is essentially the component that ensures high availability in Vitess. All right, I'm going to go over a demo now, which will be the major part of the talk. I'm going to look at different queries, how Vitess handles it, take a look at a cluster in Vitess. Before that, I'll again pause for a second just to see if someone has any questions regarding the architecture of Vitess. I see there's a question in the chat. I'm going to read it out loud so that the audience live can also see it. So the sharding scheme has to be decided during the planning phase of the database creation. It's a good question. Yes, when you do decide to shard your system, that's when you decide how you want to shard it. You can change it down the line. It's not straightforward. You do require to run a couple of operations of reshard, but it is possible to change it down the line. But the most ideal scenario would be that you you look at your data, you look at how you want to shard it, what queries you want to run. There are ways of testing out how your shards would look like, how Vitess would run those queries. So it's generally advisable that you do the planning first instead of jumping first in. For demo, it's fine. You can use whatever you want, but in a running system, generally months of planning go into this. People try out different sharding schemes on smaller data sets to see what kind of queries are going, what kind of how much latency they're seeing on different kind of queries. What can they do? Can they change their queries? A lot of planning goes into this. What is the highest QPS achievable? I don't think there's any highest. You're welcome, Ashish. I don't think there's any highest limit as such, but people have run over 1 million QPS with Vitess. There's actually a blog post on PlanetScale that talks about how Vitess runs over 1 million QPS on a benchmarking tool. I can link that blog post to you. Would you like to ask how Vitess fit in CDP space? I'm not aware of that CDP. Would you write it full form? What exactly is that question? Customer data platforms. Oh, for sure. You could use it as well over there as well, but this essentially is like a multi-purpose database. So you could use it for any of those reasons. There are some very specific use cases for some specific databases as well, like Neo4j. I'm not sure if you've heard of it, but it's a graphical database, and it works very well if your data can be stored into graphs. It's actually what was used in Panama Papers when they were doing that research. So Vitess is a general purpose database. You can use it for almost anything. You can use it for storing customer data, a few other things as well. Okay, let's go over the demo then. All right. So I already have a Vitess cluster running. We have two key spaces. We're going to look at commerce, the one that we just saw in the slides, what they were based off, and two shards in there. Okay, the shards are not serving. Let me take a look. I'm just going to bring up the cluster again. While this is going on, if someone has more questions, feel free to ask them. How does Vitess solve the trilemma of managing throughput, scalability, availability, and security? Okay, I'm going to take this one by one. So scalability happens through sharding because you can keep each of your shard to a manageable amount of data. In general, we expect people to keep the size of each shard to be around 250 gigs. So for example, if your database is 1 terabyte, then it's ideal that you keep 4 shards, each shard having about 250 gigabytes of data. So that's how we handle scalability. Throughput, again, because you have so many MySQL instances, you can keep up as many VT gates as you want. You can provision more replicas if you want for the read traffic. For write traffic, if you ever hit the limit, you can scale further. You can increase more number of shards so that your write traffic is split across each shard. And you can have as many VT gates as you want. So because it's a microservices architecture, VT gates are all stateless. You can have as many as you want. You can increase the number of shards you have. Throughput scalability go through there. Availability happens through VTOR, which is the orchestration part of Vitess. If something does go, if any component goes down, MySQL, there are some issues, maybe some MySync is not working properly, VTOR configures all of that, and it keeps pulling the instances to see if something is wrong. Security happens on the VT gate layer. There are ACLs, access control layer that you can configure there. Even an example that we're going to see, it's actually using. In the example we're going to see, we have passwords and everything. So essentially, whatever you have in MySQL, you have everything on Vitess plus more. We also do few other things like you can redact your user data in logs and few other things when it comes to security. I hope that answers the question. If there's something else, feel free to ask the follow-up question. Doesn't going through so many shards TPS reduce? Does if anyone changes the data, is it visible? Not necessarily. It highly depends on the kind of query that you run. So if you're going to run a query which is going to require collecting data from all the shards, like a very large select star or something like that, that will take a hit because you just have more data. You just have to compile more data, go through it. There's not much that you can do about it. But if you're going to have point queries, which is more likely, for example, in an Amazon case, for example, you're looking at a product and you open the web page for it, it's going to be a very specific point query where you're collecting information for a specific product. So it just gets routed to a single instance. So you don't really suffer a lot of overhead there because you're essentially just going through a VT-gate, VT tablet MySQL, and the return path. There's not much pre-processing that happens on VT-gate. There's nothing there. So even if you have multiple shards, and even if you have 1,000 shards, because you're only going to go to one shard, whether you have 4, whether you have 1,000, it doesn't matter. The only place where it does matter is that you're going to go and collect data from all of those shards. That's where it makes a difference. So it is very dependent, highly dependent on the kind of queries you run. And that's what I'm going to show you now in the example as well, that it's not just the queries, but also on the sharding scheme that you use. Because sometimes if your data is locally available, you might be able to even run complex queries such that they don't require you to go across multiple shards. If anyone changes the data, is it visible? Yeah, it is a database. If you add insert more rows, it is visible. Okay, this is running now. Cool. Okay, all the tablets are up. That's good. I was doing some testing locally before this and didn't realize that I left the cluster in a broken state. Anyways, it's all good now. Let's start. So we have a commerce key space. We have 2 shards, -80, 80- as we saw in the example in the slides. Each of them is running 3 tablets, 1 primary and 2 replicas. I'm going to show you the schema as well real quick. So ignore these sequence tables. I'm going to talk about sequences in the end if we have time. But essentially, these are Vitess' solution to run auto increment, because once you go into a sharded system, auto increment doesn't really work well because both the two have to be in sync. They can't be adding auto increment rows separately because that would not be correct as your primary key constraints if you have it on the auto increment table. We're going to talk about the sequence tables in the end if we have time. But let's look at the 3 tables that we do have. So we have an order, not the order table. Let's start with the customer. We have the customer table. We have the 2 rows only, 2 columns only that we saw, customer ID and email. We have the products, which SKU, which is the primary key. You have the description of the product and the price. And then you have an order table where you essentially have an order ID, the customer that ordered it, and what product they've ordered. Here, this is a very straightforward schema for the purposes of example. I've not done it such that within one order you can have multiple products being ordered. No, it's like one customer, one product, one order. That's it. So it's a very straightforward schema. We just have these 3 tables that we're going to be looking at for the commerce key space. Here we have a list of tablets. This is the UI for Vitess. So you can look at the different VT gates. For now, I've only spawned 1 VT gate instance because we don't require anymore. And we have the VTCTLD as well. So you can look at the UI of VTCTLD too. 0.5, 15,000, 15,099. This. Yeah, and this is where we have the VTORG. So essentially, VTORG's UI is pretty small. It just shows the recent recoveries that has run, unless something goes wrong in the cluster. There's not much that VTORG does. So we'll come back to this once we look at those. So now that we have a VT gate, we have the schema. We can actually go ahead and connect to that VT gate instance. Okay. So if you take a look at this, the server version over here, I hope this is readable for everyone. If it's not, let me know. I don't think I can increase the font anymore, but I can try. Okay, so if you take a look over here in my SQL Server, we actually report the server version to include Vitess. This is what tells you that you're actually connected to a VT gate and not to a MySQL instance. And here, this is the version of Vitess that we're running, 17.0.1. This is the latest released version of Vitess. And you connect it to a VT gate through a normal MySQL client. This is what you would use. So VTGate uses the MySQL protocol. It also understands gRPC, but we're not going to talk about gRPC today. Essentially in the MySQL protocol, you can use any normal MySQL client that you have. So any MySQL client works. Use this and let's go over. Let's take a look at the data first, what we have. There we go. So we have 5 customers. You will notice that it's actually not ordered. It's 101, 103 coming separately, 102, 4, and 5 are coming like out of order. I'll tell you why in a while. You have 3 products and you have a bunch of orders as well. So this is essentially the data that I inserted just for the demo. And you can explicitly ask Vitess to route your queries to a specific shard. This is generally used only when like advanced, like mostly for debugging, when you want to see exactly what data is stored in which shard. Applications generally would not be using syntax like this, but it is supported in Vitess essentially for this purpose, that you can explicitly ask VTGate to just send your queries to a specific shard and not worry about the correctness of it. So if you do a select star from customer now, you're actually telling VTGate, I just want to see the data that's there in this shard. So 101 and 103 is in the first shard. And that's also why you don't get them ordered, because 101, 103 are coming from the second shard, 102, 4, and 5 are coming from one of the shards. VTGate just appends them and returns them. Unless the query asks it to order them, it would not. So again, go to 80- and look at the customer there, and you would see that there are 3 rows over here, 2 rows over here. Together, they make the entire data that you have. Go back to comments. All right, so we're going to start by looking at different queries that you can run and how Vitess handles them. So the first one being just a join. Let's say that you have all the orders and you just want to join with the products on the product ID just to get back the description of the orders. So for each of the orders, you just run a very straightforward join using SKU, and you get all of the information back about the different item that was ordered as part of it. There is one extra command that we've added to Vitess. So you're aware of explain, right? Explain is a command that MySQL offers, which essentially tells you how MySQL is going to run that query. It gives you more details so that you can debug your query and probably use it to improve the performance of your query. Similarly, Vitess, we've added a new command. It's called re-explain. It essentially does the same thing, but it holds the information from the Vitess standpoint. So you can run something like this. And this essentially is just to re-explain. It's saying, give me the plan that Vitess would use to run a query like this. So let's think about it. Let's say you have the C order table, you have the product table. How would you do a join between the two, given that it's a sharded system? So because it's sharded and you don't necessarily know, I forgot to show you the sharding scheme on the tables. Let me go ahead, show that for a second. Key space, commerce, and there we go. Okay, so the sharding scheme for the tables is the column index, the first one. Essentially, the sharding scheme is just for the customer table, we are using the customer ID column, and we're using a hashing function on it. So you use the hashing function, whatever you get back, that tells you which shard your function goes to. So essentially, it's dependent only on your customer ID. And the same is true for your order table as well. So C order is also sharded by the customer ID. What this means is that if you have a customer 101 and you have the orders placed by that customer, they would always live in the same shard, because order table is also sharded by the same column. And if 101 as a customer is going into the first shard, the orders from that customer will also go into the same shard, because you would still have the same customer ID. You're using the same hashing function. So it's deterministic. You get back the same shard every time. So all the orders for a certain customer live in the same shard. And for the products, we're doing a hash on the SKU. Essentially, because your sharding scheme is such, there is no correlation between C order and products. So if you run a join like this, you essentially have to just get back all the data from MySQL from both sides and run a join on the VTGate level, because you don't know, because you can't push the join down to MySQL. You could have a product living in shard 2, but the order in shard 1. So VT-gate has to be the one that sees, okay, this product is on the second shard, this product came from the first shard, and I need to join these two data. So if you look at the plan that VT-gate produces, you would actually see that within it's a join that's happening on VT-gate, and you have two inherent routes that it's doing. It's doing a query to the order table first, and once it gets back that data, it's going to do a query to the product table, asking for the specific order that it got back. So it would select all the orders. For each of the orders, it would get back the corresponding product that is required, accumulate that information on VTGate, and then send back the results. So the result you get back is essentially what any MySQL instance would give you, as though you were running a single monolith, but under the hood, Vitess is running a lot more. As part of this query, you can even get back exactly the queries that VTGate is running. So if you do that, let me just remove this. It's easier to look at. So you actually see the queries that VTGate is running. So first it goes to 80-shard, gets back all the orders, goes to -80-shard, gets back all the orders. And for each of the product corresponding to that order, it runs another select query. So this runs SKU 1002, lives in the second shard. So this query goes to the second shard and so on. So this is what I wanted to show, that essentially when you run even a straightforward join, because your sharding scheme is not conducive for it, you could essentially end up running a lot of queries on the MySQL instances, because there's a lot of processing that has to happen on the VTGate side, essentially because the data is split across and it's up to VTGate to accumulate that information. If, however, you did the same thing, but you wanted to do a join with the C order, you have the order, but you want to join with the customer. You don't want the product information, but the customer email who's ordered it. So, and if you do a join like this, you can run the same. We explain queries over here, and you see there are actually only two queries. And the reason that is because of the sharding scheme. Because the way that the data is sharded, your customer, for each of your customer, all the orders will live in the same shard. So when you're doing this join, you can actually just do this join on each of the individual shards. VTGate doesn't need to do any accumulation as such, apart from just appending the results. And that's exactly what Vitess is doing. Like it just sends the join query. You have a join over here. You're selecting from two tables, C order and customer, on where you have this join condition, and you're sending the same query to both the shards. So your sharding scheme makes a huge impact as to the amount of queries that Vitess would have to run, which is why when you go into a sharded system, you spend a lot of time figuring out what is the best sharding scheme that works for you, not just for the distribution of the data, but also from the queries perspective, because for a given application, you generally already know what queries it's going to run, what are the structure of the queries that it's going to look like. Maybe the data would change a little bit, but the overall structure remains very similar. In that sense, this is why you spend a lot of time trying to figure out what the best sharding scheme is. In this scenario that we've chosen to prioritize keeping the customers and the orders together and not the products, which means we're anticipating that we would be running queries like this far more frequently than the ones that are joining with the product. And these are the considerations that you make. Okay. Okay, I see that there have been a few questions. Let me go over them. There's a question which I'm going to read out the question. On what basis are we performing sharding? Are there any standards, or is something based on frequency? Basically, on what factors sharding scheme depends. Sharding scheme depends on various factors. So you can, the way that generally sharding works is that you select a bunch of columns and you create a function that's going to run on those columns. And that should give you back which shard the data is supposed to go in. And what kind of function is going to depend heavily on your own data. It's a very personal decision based on the data that you have. For example, in the Amazon case, when you would shard a customer table, you would want to keep it. You would want to give a lot more weightage to the region where the customer is in, so that most of the data for each customer in a given region lives closer to that region, and the query latency is much lower. So there are various reasons, various factors that come in. You would also want such that your database is data is well distributed. Like it would not make sense for you to use a sharding scheme that is going to send 90% of your data to the first shard and only 10% on the second one, because that is very highly imbalanced, right? So various factors come into when you choose a sharding scheme for your table. What column you're gonna use, that's a major impact. So even in this case as well, the one that we just looked at, in the order table, if you would use SKU as your sharding scheme instead of your customer ID, that would have made a huge impact. Your first query that we saw where you were joining with product, that would have become a very straightforward query where you're just sending the two joins down to MySQL. But your customer query would have become far more complex. It would have taken a lot longer to run because it would have needed to accumulate all the data from both the shards first. So yeah, these are the factors that you consider when you select a sharding scheme. There are no as such very explicit standards. You do get a lot of inbuilt functions that come out of a test. The one that I'm using right now for this demo is one of those. So you can essentially you can just select a column and XX hash. This is one of the most straightforward functions. You just hash a given column and that's it. And that gives you back a value which defines where your shard goes. It's good in the sense that because it's a hash function, it's generally very well distributed. So your data gets mostly evenly split, like we saw. Even when we inserted 5 customers, 3 went to one shard, 2 went to the other. It's generally a very good distribution. You don't get a lot of skew. Other factors also come in, like resharding. When you do decide to reshard your data, how much data would you have to move, stuff like that. But yeah, there are other factors as well. This is itself is a complex enough topic for a lot of folks to spend a lot of time on when they do decide to shard their data and how they would prefer to do it. Yeah. Okay. So, are there any more questions? Should we move on? Okay, I don't see any more questions in the chat right now, so I'm gonna go over the next query. So this is what happens when you're. These are the contrasts that you see based on the sharding scheme between the two queries that you run. That one of them is running like 8 queries, the other one is just running 2. Let's look at a few more complex queries. Let's say that you want to find the amount of sales for each given product. So you would essentially run something like this, that you take the product, you do the sum of the product by joining it with the order table, and then you group by that product. So you just get back the product, its description, and the total sum of the different orders that have happened. So you get something like this, which in itself is. So it's a very good exercise in general to think about how you would actually run this query. You see the result that you got back. This is the result that you want. But even if someone just told you how would you run this query, given you were in place of VTN. So you have 2 products, you have 2 tables, both of them for product and a customer, product and the order, both sharded. Some of the data lives for the product lives on one shard, some on the other. The order lives same way, sharded on both the systems. You don't know they're going to correspond to each other. A product could live on the first one. Its corresponding product could be on the second shard. The order could be on the first shard. So how would you even run this, even if you had to do it manually? So essentially what you would do is you would first take one of your products, you would find all the orders for that product in both the shards. Once you've got that, you would see how many orders you finally accumulated, multiply that with the price that you have, and that is the sum that you finally get back, right? And this is what you would do for all the products. And essentially, this is what you see that Vitess does. So there are 2 ways that you can do this. You can do it first from the order table, that you pick up all the orders first and the count of each of those orders. And then for each of those orders, you find exactly which product there is, and then you sum those up. Or you do it the other way around. You first select from the product table. And because of these multiple alternates, this is where other more complexities come into VTK. Right now, we're just looking at joining 2 tables or selecting from 2 tables. But there are queries where you end up selecting from 5. But then that question comes in: which tables do you join first? Because you also have to consider the data set that you're carrying on VTK. If you have 2 small tables, you join them. You would end up with like 2 rows which you join with the other table. But if like one table is huge and you end up joining that with the first one, then you might have a lot of data that you're keeping in track, which eventually would not survive because you're then going to join with a small table, which eventually would probably kill all the rows. But this is where the complexity also starts growing, that now that you have so many different options, so many different plans that you can choose from, how does Vitess handle it? So we have various algorithms for it, where we try to merge different routes. We try to optimize on the network calls, but there's a cost model that we're working on as well. Eventually, that will land up in Vitess, where we're going to look at the size of the data as well. So it's it's a very complex problem when it comes to this, that you have these different options to choose from, and which plan do you choose? You want to basically find the plan that takes the minimum cost. But that cost is also not easy to estimate because you don't always know how much data you would have when you run it. You plan it once, then you run it multiple times during execution. And that execution could be different at different times. So here we can look at the plan that VTGate comes up with. Okay, so just of the offset, if you look at the nesting, you know that VTGate is doing some work. The first thing that we have is it's essentially a join between an order and a product order and the product table. So that is something that you definitely have. You have a join between the order and the product table, running a couple of queries. But once you do have completed the join, you have to sort the data as well because you're going to run a group by. So you need to sort the data based on the SKID, SKU that you get back from the price, because those SKU from the left and the right come in, but they need to be sorted because you're going to run a group by. Once you sort the memory sort, and then you do something like this, and you take the third column, second column, you multiply the count of the orders that you have and the price of the individual product, and then that's what gives you your result back. Essentially, that's what Vitess is doing over here. It's running a memory sort on VT8 and then doing a projection where it's multiplying a couple of columns to find the final value that it needs, and then it aliases them as expected in the query as total sales, description, and SKU, and that's what you get back. So when it comes to serving queries, even straightforward queries, which you would expect to not take a lot of toll on the system, they do, because the way that you've sharded your data, because you're doing a sum, it requires you to do you're doing a group by, it requires you to sort the data that you have to group them, and then you're doing a sum on top of it. So it requires projection as well. And then let's look at one. Well, I'm going to just go over one final query. This query is essentially finding out the customer who's ordered the most expensive item. So the way that this query is written is that you first find out what the most expensive item is as a subquery. That's basically just find the maximum price of all the orders, right? Because each order only has one item. That's the schema that we're running with. So you just find out the maximum price from the orders table that is joined with the product table, and you get back the most expensive item that has ever been ordered, right? And now that you have it, you basically just find the customer and join it with the order table to find which customer was the one that ordered, which placed an order which had the same price as this. So you do a join, you join with the product, and then you essentially just have a where condition where you say, give me all the customers that have ordered anything with the price of this. But a customer could have ordered the same thing multiple times, so you also do a distinct. I actually have data for that. So if you don't do the distinct, you get back a customer twice, because you have the customer 103 that has ordered the same monitor twice. So if you only want distinct data, you only want the customers list of customers, then you do distinct. This is essentially the query that you would run. And if you look at the plan that VTGate has, it again, the first thing that it has to do is it's a pull-out subquery. The subquery is not correlated. If you look at the query, you would realize that this has nothing to do with what you were doing outside. You can run this once, you can find the result of this, you can essentially just replace it. For example, if this were to turn out to be 100, this is a valid query, and then this is essentially what you're doing. So this is what Vitess figures out. It's no longer a correlated subquery. You don't have to run this for each row that you would have gotten back. It's uncorrelated subquery, so you can actually pull it out. So you can run the subquery first. And once you've run the subquery, then use that result to run the remainder of the output that you have. And that's what it does. So you first find out the maximum price. And once you've found that maximum price as a subquery, the maximum price is again a join. So that itself is a join between the order and the product table. And you get the maximum price out. Once you get the maximum price out, you use that to do a join between the order, product, and the customer table. To finally figure out exactly what you're supposed to do. So one thing that you would look at over here is that when you're doing a join between three tables, because essentially in the final outer query, you would see that you have a join between C order with customer and then again the product. Vitess does figure out, even in this part, that order and customer are together, so it can still join them together and merge them in a single route because the way that the join is written. So you can push that predicate down to one side, club the join together, but the join with the product table still has to happen on the VT-get level. And once you've done all of this, then you do a distinct, and for the distinct part, you again require ordered aggregates, and then you choose the distinct elements from it. So you create a hash table on VT-get, and using that hash table, you find the unique values. And from this, if you look at the queries that Vitess ended up running, you get something like this back. So you first have to get back the orders, you find the maximum price for each of the orders from the product table. Essentially, this is what is run for just getting back the maximum price. Once you have that, then you do the join on the other side, which ends up running all of this. So you end up essentially running 16 queries. You end up running 16 queries overall to get back this result. And these are again queries which aren't that complex. These are queries where customers are just trying to find the one that ordered the most expensive item. And there are a lot more things that are left. So this is just the tip of the iceberg. We've not encountered left joins yet. So example, I'm not going to go over these queries. I think it would be a good exercise if you looked at these queries on your own. Try to figure out how you would do it if you were instead in place of VT. That's actually how we kind of write this code. We first try to figure out what are the correct steps, what are the queries we would need to run to get back from MySQL. Once we understand what we need to do, that's what we code out. That these are the things that we need. This is how the data should flow through different operators. So it's a good exercise for all of you to go through. So I've written down a few other things over here, but not I'm not going to go over those. So from the left join perspective, you could basically ask what is the total revenue for each customer. Now there could be customers that have not ordered anything, but you still want the revenue of that to show up as 0. So it's going to be a left join because you don't want to get rid of the customers that have not ordered anything if you join it with the order table. So it's a left join with the order table and then a join again with the product table, and then you do the sum. This will give you back the total sum, total revenue for each customer, essentially. So you get back each customer how much money they've done. This requires left join handling on Vitess. You could have unions. So you could run 2 separate selects and then unionize the results. Sometimes the unions can also be merged together and sent to MySQL. You could have derived tables. We've not talked about those. We've looked at subquery as such, but this is a scalar subquery which is guaranteed to return a single value essentially. But you could also have derived tables where you're creating a table first and then using that. For example, you want to find out which customers have ordered multiple items. So you would first find which orders have been ordered multiple times and then join it with the customer. There are various ways of writing it. Sometimes you can even rewrite these to not require a derived table. That is something that Vitess also does. We have a bunch of rewrite rules before we start planning a query to get the query in the simplest variant that we can possibly get it to, so that planning it is much easier. It goes through multiple phases. Then finally, you could even have correlates of queries. We've not looked at those. Vitess handles all of these. There are cases that there are still queries that don't work with Vitess, essentially just because of the complexity of it, that we're not able to handle them all. But there's a lot that does work. So this is essentially the challenges that you face when you're looking at query serving in Vitess. I'm going to quickly show, because we have like 5 minutes, I'm just going to spend a little bit of time on this as well. This was VTORC, the orchestrated component that I talked about. This is something that I've worked on in the past. And if we look at the tablets that we've had, for example, let's just look at the -8 shard. You have 102, which is the primary, and you have 2 replicas, right? And we have VTORC, which is running. So let's say let's try and simulate a scenario where the primary goes down, right? So I'm just gonna shut down the MySQL instance, but this could happen for various reasons. This could be a network partition because you're running so many instances and you're running them all on Kubernetes. Anything can go wrong. Your network could get partitioned. Your tablet could get oomed. Various problems can happen. Essentially, even on the cloud, you're just running servers, right? That server could crash. So I'm gonna simulate something like that. Let's say that 102, for example, and oh yeah, I have to run it over here. There you go. So it's going to shut down the MySQL tablet for 102. So your primary is going to go away, and then you're going to expect VTGate to be handling that failure. You look over here, then you see that there is a recovery that VTGate ran, and it's the recovery called dead primary because your primary tablet is no longer available, it's dead. And what it does, it essentially just reparents a different tablet in its stead. And you now see that 101 for that same shard is now the primary which is serving, and this tablet is not gone into a not serving state. So because VTORG is available, you can handle certain amount of failures and still continue serving traffic. We also have buffering on VTGate. So while this goes on, you have some queries which would have otherwise failed because your tablet is down, but buffering also is there on VTGate. It mostly works for planned operations and few others. I'm not entirely sure how much queries you would be able to buffer in this scenario, but buffering provides a little bit of extra wiggle room in case you do some kind of planned operations. You want to take a server down for maintenance. You don't end up returning queries for the returning errors for the queries that you would have gotten during that time. During the time that you're cutting over from one tablet to the other. They all just get buffered on VTGate. There is a window, there is a limit, exactly how buffering works. Basically, you have a certain limit. You exhaust that much space, then you start dropping queries. But more often than not, you can configure it such that you don't end up seeing any errors as far as planned operations are concerned. So this is the high availability side of Vitess, that you run multiple tablets, and if something goes down, then there is a tablet that can come in its place. We ensure that data viewability is maintained by semi-sync. I'm not entirely sure how aware you are of semi-sync in MySQL and what the trade-offs that you get from it. But the durability policies in Vitess are built around it. So essentially, the durability policies allow you to configure what kind of durability you want, how many tablets you're going to run, how many semi-sync acts are you going to require for accepting a write, and this is going to affect the number of failures that you can handle. Essentially, you're running 3 tablets, right? In the example that we have, so you definitely can't handle more than 3 failures, right? If all the 3 tablets go down, who's going to take the writes? So there is a certain limit to the amount of failures you can handle, but you can essentially that's the thing that you configure how many tablets you're going to run, and because each tablet is going to have a cost associated with it. You're running a server at the end of the day, so you take a call as to what kind of availability you want. It would be a once in a blue moon sort of a scenario that 3 of your tablets all go down, so you're probably fine with something like that happening, because now that this tablet has gone down, you can actually even go over VTR. It has an API endpoint which tells you if there are any problems in the cluster. And if you look at it, it will actually tell you that zone 102 is not in a good state, and the problem is that its last check was invalid because it's dead. So even if you keep polling this, there are issues that VTR is not able to fix. For example, VTR can't repair a VT tablet, right? It doesn't control it doesn't control MySQL uptime as such. The server could have crashed. So all of these things, that's something that whatever VTR can't handle will end up showing up over here. In which case, some other component would require handling it. More often than not, this would fall into the part of Vitess operator. If you're running it on Kubernetes, if any of your component crashes, VTR the operator would restart it. Once it's restarted, VTR would configure it properly, but someone requires to either manually you would restart it or through the operator. And that's how high availability in Vitess works. I could have gone over a few other examples showing you multiple tablets. If you have 3 tablets, what happens, different durability policies. But for curtailing the talk to and keeping it a little focused on query serving, I've chosen not to do that. I'm just going to go over a couple of features that we've skipped over in the past. I can talk about sequences. We've got about 10 minutes, so I can spend 5 minutes on sequences. This is another interesting problem when it comes to query serving. But MySQL offers something called auto increments, right? I'm sure all of you have had used it in the past, that you create a table with an ID. You would always end up creating auto increment column. On that ID, you would set it to auto increment, but auto increments don't work very well when you're in a sharded system, because you now have 2 shards. And if the 2 shards individually ended up assigning the same auto increment value to 2 rows, you've now broken your primary key constraint. At least in a logical database. Like maybe on MySQL, it's still fine, but on the logical level, now you have 2 customers which have the same ID. That's not great, right? So the way that Vitess handles that is by a sequence table. Essentially, what we're doing is that when writes come in, Vitess will internally override the auto increment value with a certain value instead. The VT gates cache certain amount of values that they're going to use for those auto increments, and that state is stored in the sequence table. So if you look at a customer sequence table, it basically says that just has like one row. This table always has one row. It just says that what is the current ID that what is the next ID to use when an insert comes in, and what is the cache basically? How many values you're supposed to cache? So essentially, if the value is 1,000, basically what will happen is VT-gate will take this table and it'll cache. If the value is 100,000, it'll just cache 1,000 values with it. So next 1,000 inserts that come in, those values will be assigned incrementally. So each VT-gate would cache 1,000 values separately. And that's how you ensure that you always have auto-incremented values. You still get the disadvantage of this approach is that you sometimes get holes. For example, a VT-gate ended up caching 1,000 values, but it crashed after only assigning 30. Those values will never be assigned to some other VT-gate ever again. So you just have holes in your database, but that's fine. That's the trade-off you make when you use when you have to get a same behavior of an auto increment, such that your application is not providing that ID. So VT8 takes over that role. It provides that ID by caching a certain amount of values and then storing that state in a separate unsharded key space for that. So that's how we handle the problem of having an equivalent auto increment thing. We have a few other features. MySQL compatibility, of course, is something that we continue working on. We keep adding compatibility we checking compatibility with popular frameworks. We ensure that they continue to work because there are certain things that each framework does very specifically. For example, Ruby on Rails, when it starts, it runs a bunch of information schema queries to figure out what foreign key constraints live where, how is the data structured, stuff like that. So all of those have to work with Vitess. We have other management features as well, which make Vitess a lucrative thing to run, even if you're in an uncharted environment. For example, connection pooling. MySQL does not handle a lot of connections very well. Each connection creates a thread, and it's not lightweight. You can't have a lot of connections to MySQL directly, but the connections to VT-Gate are far more lightweight, and VT-Gate does connection pooling. So if you have 3 clients connected to the VT-Gate, which are running in the same in a similar environment, VT-Gate will actually just have one connection to VT tablet, and we just reuse that for each of the 3. So we have connection pooling on VT-Gate level. You can have multiple VT-Gates as well. So you don't generally run into the problem of having, you don't exhaust connections with VT-Gate because you can just scale them out indefinitely. We have online schema changes. I'll just briefly talk about this problem as well. So when we're creating our own projects, especially in the college and stuff, we don't worry about this all that much because the data that we're running with is very small. So you have like a table which has like 100, maybe 1,000, maybe even 100,000 rows. That's not much. And if you, let's say you alter that table and you just insert a new column, or you alter that table, you add a foreign key constraint or something like that, it doesn't take a long time. Like it just takes probably like 2 seconds, 3 seconds, maybe 5, and it's fine. But now consider something like Amazon. It has like terabytes of data in a table, and they want to add a new column to it. Maybe even a generated column, or maybe they want to add a foreign key constraint or something like that. Or they want to rename something. If something like that has to happen, you cannot afford that operation taking days and locking your table, because all of the schema change operations in MySQL, large extent of it, there are some that happen instantly, but a lot of them will lock the table entirely. Like none of the writes, none of the reads would go through while that change is happening. For that reason, you require something called online schema change, which does these schema changes for you, but in an online fashion. Essentially, what Vitess does is it copies over the entire table, does the schema change separately while keeping that table up to date, and then flips the 2 table around. This is a very simplified version of what it does. Under the hood, this is far more complex. But this is essentially what you get when you're using Vitess. You get online schema changes as well that you can use. You get query consolidation. We've already talked about a few of these features. We've talked about sequence tables, multi-line views, change data capture, and data migrations. I'm not going to talk about these. These require knowing replication. It's one of the components of Vitess. Essentially, Vitess has the capability of parsing binlog events that MySQL writes and uses those to offer some more lucrative features like multi-line views and change data capture, but I'm not going to talk about those for now. I'm just going to conclude now. I'm going to leave 10 minutes for question answers. So I have a few resources towards the end of the slide. There's the Vitess Slack. If you have any questions, if you're interested in running Vitess, you want to know more about it, you have some questions, please feel free to join that. All of the maintainers are on that Slack, and we answer questions. We help out people if they're running their own clusters of Vitess. You can try out one of the tutorials on the website. The source code is also linked. And a few of the resources. There's a blog on query planning that one of my colleagues wrote. And this is talking about the different complexities of query planning, the one that we just talked about, but in a little more detail. It starts with the very top, the parsing side, which I didn't talk about today, the parsing, the semantic analysis, none of these. But these are the different phases that you go through when you do the do planning in Vitess. So there's that blog, and there's a blog on cluster management as well on Vitess Orchestrated. This is a blog that I wrote. And it talks about the different things that VTR does and how it does those. Yep, I'm open for questions. And that was the end of the session. I hope that was enjoyable for everyone and informative. Feel free to ask any questions if you have any. If you think of more questions later, you know where to find me on the Vitess Slack or by email or on Twitter as well. Although I don't use that as much.
Thank you, Manan. Do you have any question from the audience? So the plan is I'll give you the mic if you have a question, and this mic will basically record all the things and he can listen to it. Any question from the audience? No questions? Everyone has understood everything Manan has said? Manan, do we have any online questions?
I've answered all of those, I think, as far as I know. Yes, I answered this, answered this, answered this, answered this. Yep. I've answered all the questions that were there online. If I missed any, please feel free to post them again. I'll take a look.
Yeah, this is very interesting. Like, thank you for explaining the Vitess architecture for us. And I really love the hierarchical architecture, which is like taking basically modularizing the queries and balancing the load that way. So it's very good for, as you have shown, that handling availability as well as performance at the same time.
Yep. Those are all the considerations that we had in mind when the authors of Vitess built it. Vitess is actually a French term which means speed. And this is not a name that it originally had. It was a different name that when they tried to make it open source, it clashed with one of the already existing systems. That's when they chose Vitess as a name then. So this is a brief little history on why Vitess is called Vitess.
So what's the future for Vitess? Like you already
yeah, I didn't talk about that. So there are a lot of things that we have ongoing. The major part of it is foreign keys. I'm actually working on that right now. On the query serving side, because we don't have because foreign keys in a distributed system become a very hard problem because now your data is distributed. Vitess essentially has to handle all of those on the VT-gate level, ensure that you don't insert wrong data or of the cascade operations, everything goes through properly. So that's what we're working on right now as a query serving team. We have ongoing work for compatibility that we keep doing. Other than that, there are a few other things in pipeline. And yeah, please check out Vitess. We've listed out everything that we're doing right now, what's going on in the next release, and the things planned for the future as part of it.
Oh, that sounds great. I mean, you have already shown that Slack is 100% on Vitess, which is a big deal because Slack generates a lot of like big data. Like they generate like texts, images, videos, like lots of posts of like different variety of data at a very high volume and velocity. So I think that means that more and more organizations would rely on Vitess.
Oh, for sure. We would love that. The more organizations use Vitess, the better it would be for the project. We're always looking for open source contributions. So if any of you feel like it, please do look at the project, try to contribute to it. We do apply for Linux Foundation mentorships as well. I think we have one this time around, but we have a tool called RV Fast Yet. It's a benchmarking tool for Vitess, and that's what I think our intern is working on right now. The future as well, if you're interested in open source, LFX and GSOC are two very good outlets for it, and Vitess applies to both. when we have suitable projects for interns.
Okay. Thank you for sharing all the resources. Like apart from your talk, like sharing all the your blogs and other resources. Oh, so there is a question from the in-person audience. So I'll just get to him.
Sir, I would like to ask, is it open source so like we could contribute and like apply for GSOC and like maybe contribute to the code of Vitess?
Oh, yes, it's completely open source. You can contribute to Vitess. And Vitess applies to both GSOC and LFX. We've applied to GSOC, I think, a couple of times. LFX, we're a little more consistent in. I've had LFX interns for a while because one of the parts of query serving is also parsing, that you need to be able to force parse the query before you can support it. And MySQL keeps adding new functions, new syntaxes. So that's what those LFX terms were around. And that's actually how I started working on Vitess as well. I first initially started adding parsing support for Vitess. At this point, our parsing language, the YAC file that we have, is over 7,000 lines. And we just keep adding to it because there's more and more that MySQL supports that we have to do. So we have multiple projects in Vitess that we apply for NFX. So if you're interested, please take a look.
Thank you, sir.
You're welcome.
Yes, I think we are almost near the time. And so let me thank you for, let us thank the speaker, please. So there are other seats as well. So the entire room is not visible, like not all the audience are visible. Also for the online audience, do you have any questions? You can like unmute and ask if you have any questions as well. You can also post it on the chat. Okay, I think we don't have any immediate questions. So I think that it was very enlightening for all of us for learning about distributed databases, which is the only database that is going to be there in the future because everything is going to be distributed. So thank you, Manan, for explaining the architecture in details and then giving us a demonstration of Vitess, where we saw that how queries are being distributed. The vExplain feature was fantastic, like no words there. So thank you so much. Thank you so much for your time, and thank you so much for talking about Vitess today. And thank you so much for the audience here and audience online for listening to, tuning into Manan's talk. And hopefully we'll learn more about Vitess in the future, as well as wish you all the best, Manan.
Thank you very much for inviting me. I had a blast.
Yes, you have the last words.
Yeah, thank you very much for inviting me. I had a lot of fun delivering these talks.